Hello class, this is Stat 1200. I am your instructor William Bjolman, and today we are covering section 3.1, Measures of Center. Our objectives for today are to be able to compute the mean of the dataset, compute the median of a dataset, compare the properties of the mean and median, and to find the mode of a dataset. So first we're going to go over computing the mean. So we have a list of n numbers that are each designated by x1, x2, and so on. This symbol right here is called summation. So that E looking thing is called a summation. So that represents the sum of these numbers. So what this is saying right here is the sum of the xi's is equal to x1 plus x2 plus x3 and so on all the way to xn. So first we have the sample mean, which is given by, we call this x bar, and then we use that summation of the xi's over n. So x bar is equal to the summation of the xi's over n. That is the sample mean. It's denoted by this x bar. So next we're going to go over the population mean. Which now we denote it with this other symbol we call mu. It is still the summation of the xi's, but over capital N. So here, little n just represents a sample, big N represents a population. So here we're going to do an example. So this is our first example. During a semester, a student took 5 exams. The population of exam scores is 80, 83, 95, 68, and 85. Find the mean. So since this is a population, we're going to use mu is equal to the sum of the xi's over big N. So our xi's are 80 is the first one, plus 83 is the second one, plus 95, plus 68, plus 85. So those are our x terms. Each are the test scores over big N. And how many tests did we have? Well, we had 5. So now if we add those numbers up, we get 411 over 5, which is equal to 82.2. So the mean of these 5 scores is 82.2. So here you're going to pause the video, and these are some practice problems for you to do. So you're going to do these 4 problems, calculate the mean for each of the data sets. You can treat them as samples, and go ahead and calculate what the mean is. The answers will be shown in 3, 2, 1. So here are the answers to the problems. So the first one, we get the mean is 23.4. For the second one, we get the mean is 3. For number 3, we get the mean is 5.5. And for number 4, we get the mean is 81.5. So hopefully you got those same answers and you understand. The median is another measure of center. The median is the number that splits the data set in half, so that half the data values are less than the median and half of them are greater than the median. The procedure for computing the mean differs depending on whether we have an odd or even number of observations. If we have an odd number of observations, the median is the middle number. If n is even, then the median is the average of the 2 middle numbers. When you're doing this, you have to be careful though, because in order to calculate the median, you need to make sure you first arrange the data set from smallest values to largest values. If you don't have them arranged from smallest to largest, you cannot just pick out the middle number. So make sure you do that before you try to calculate the median. So here is example 2. We're going to find the median now for that data set of test scores that we just had. So first thing we need to do is we need to arrange the test scores from the smallest to the largest, as I said before. So 68, 80, 83, 85, and 92. So now that they're organized small to large, we go, okay, do we have an odd number or an even number? Oh, we have an odd number of observations. So it's the middle number, which is this number right here. There's 2 to the left and 2 to the right. So then our median here is 83. So now we're going to do example 3. 8 patients undergo a new surgical procedure, and the number of days spent in recovery is the following. We're going to find the median for these. Since we're finding the median, the first thing we need to do is organize the numbers from smallest to largest. So that is 12, 13, 13, 15, 19, 20, 21, and 27. So now we go, okay, do we have an odd number or an even number of observations? Well, we have an even number of observations, so now we have to take the average of the 2 middle numbers. So here are our 2 middle numbers, so we're going to take the average of that. So 15 plus 19 divided by 2, which is equal to 34 divided by 2, which is 17. Thus, the median is 17. So here is another practice for you guys. So now you're going to find the median of these 4 data sets. So go ahead and do that. Pause the video right here. Find the median for each one. The answers will be shown in 3, 2, 1. So here are the answers to these 4 questions. The median for the first one is 26. The median for the second one is 15. The median for the third one is 14, and the median for the fourth one is 93.5. So hopefully you guys were able to get these and understand the difference between even and odd when calculating the median. Now we're going to look at some properties of the mean and median. A statistic is resistant if its value is not affected much by extreme values, large or small, in the data set. So if there's really large values or really small values in a data set and the statistic doesn't change much, we call it resistant. So we have the median and the mean. The median is resistant. The mean is not resistant. That's something you guys are going to want to remember, that the median is resistant to extreme values, the mean is not. So here we're going to do an example to show you how that works. So I took the exam scores we had before and I replaced the exam where they got an 83 and I said, let's say they did really bad that day instead and they got a 13 on their exam instead of an 83. What happens? So this will allow us to see how resistant the mean and median are. First, we're going to calculate the mean. Again, we calculate that by summing up the xi's and dividing by n. So we have 80 plus 13 plus 95 plus 68 plus 85 over the 5 observations, which gives us 341 over 5, which is equal to 68.2. So we've now calculated what the mean would be. So now we're going to calculate the median. So remember, in order to calculate the median, we have to arrange the data values in increasing order, so from smallest to largest. So here they are, 13, 68, 80, 85, and 92. And since we have an odd number, we just look for the middle number, which in this case is 80. So we see the mean change by almost a letter grade and a half, because before it was around 82 and now it's 68. That's over a full letter grade just by one observation changing, whereas the median really hasn't changed much. So thus we can see that the median is resistant. So if we know some things about the mean and the median, we know some things about the shape of the data. Mean and the median are used to measure the center of a data set in different ways. When the data set is symmetric, that tells us that the mean and median are equal. So if we have a symmetric data set, we know the mean and median should be approximately equal. They may not be exactly equal, but they're going to be pretty close. When a data set is skewed to the right, there are large values in the right tail. So there are very extreme values in the right-hand tail. Because the median is resistant while the mean is not, the mean will be generally affected more by these larger values and be pulled to that right-hand side. And in that case, we see that the median will be less than the mean. So in the cases of where the data is skewed to the right, the median is less than the mean. Finally, we have skewed to the left. When a data set is skewed to the left, the mean is often less than the median. So again, like in skewed to the right, but since the more extreme values are smaller now, that affects the mean by pulling it down instead of pulling it up as it did in skewed to the right, where the median has not changed. The median stays roughly the same spot, but now the mean has been pulled down to that left-hand side. So those are the three cases. So just to recap, when data is symmetric, the mean and median are approximately the same. When we have a data set that is skewed to the right, the mean is bigger than the median. When we have a data set that is skewed to the left, the mean is less than the median. In addition to the mean and median, we also have something called the mode. Another value that is sometimes classified as a measure of center is the mode. The mode of a data set is the value that appears most frequently. So whenever you think of mode, it's most frequent, most often. So what value is in the data set the most? If two or more values are tied for being the most frequent, they are all considered to be the mode. So if we have two values that appear the same number of times and it's more than all the rest, then we have two modes. If you have three values that appear more than everything else, then it's three modes, and so on. If all values have the exact same frequency, so all values appear the exact same number of times, we say the dataset has no mode. So we're going to do another example with that dataset from before of the student who took 5 exams. So the population of the exams were again 80, 13, 95, 68, and 85. Find the mode. So if we're going to find the mode, we're trying to think, okay, which one of these appears most often? Well, they all only appear once. So since they all only appear once, none of them appears more frequently than the others. So thus, there is no mode. So here we're going to do another example. So this is example 6. 10 students were asked how many siblings they had. The results that are arranged in order were 0, 1, 1, 1, 1, 2, 2, 3, 3, and 6. Find the mode for this data set. So we're looking at this data set and we go, okay, which number appears most often? The number that appears most often is 1. Mode is 1. Here's example 7. Another cool thing that we can do with the mode is that we can't do with the mean and median is we can use categorical variables. We don't need quantitative variables. We don't need numbers. We can do it with just categories. So here we have a list of cars and we want to find the mode. So if you look at it, Toyota appears most often. So thus Toyota is the mode. Since Toyota shows up 1, 2, 3, 4, 5, 6 times, which is more than any of the other manufacturers. Here's some practice for you guys. So you're gonna find the mode for these 4 problems. So go ahead, pause the video right here, find the mode for each one. The answers will be shown in 3, 2, 1. So here are the answers to those 4 problems. For the first one, it's 27. For the second one, it's -20. For the third one, it's 28. And for the fourth one, it's 98. So hopefully you guys were able to get those. If not, you can always email me and I will respond, or you can come to office hours. Here's another practice problem for you guys. You're gonna find the mean, the median, and the mode for this data set, and I just organized it in a stem and leaf plot just to remind you guys of what that looks like. So go ahead and use this to create the data set and then find the mean, the median, and the mode. Have you guys pause the video right here, do all that, and then hit play. The answers will be shown in 3, 2, 1. Here's the solution. The mean is 30.4, the median is 29, and the mode is 27. If you guys had any problems getting that, you weren't sure how to make the data set out of the stem and leaf plot, go back, review how to do that. If you're still not sure, like I said in the last one, just send me an email and I will help you guys. Here's another practice problem. Again, you're gonna find the mean, the median, and the mode for the following data set. So the following table represents the number of shots that can be taken on a fully charged battery of 19 digital cameras. So go ahead, find the mean, the median, and the mode. As normal, pause the video and hit play when you're done. The answers will be shown in 3, 2, 1. Here are the answers I got. The mean is 201.316, the median is 200, and the mode is 220. Here's a final practice problem for you guys. The following lists the weights of offensive and defensive linemen for the New York Giants. I want you to find the mean and the median for the offensive line, the mean and the median for the defensive line, and then tell me, are offensive or defensive linemen heavier than the other? So are offensive linemen heavier than defensive linemen? Are defensive linemen heavier than offensive linemen? Or are they about the same? So go ahead, pause the video, work through it, and the answers will be shown in 3, 2, 1. Here are the answers. So the mean and the median for offensive linemen, the mean is 296, the median is 302.5. The mean and the median for defensive linemen, the mean is 285, and the median is 285. And finally, the third question, who tends to be heavier, or are they about the same? Well, we see for offensive linemen, the mean is about 10 more than the mean for defensive linemen, and the median is about 20 more than the median for defensive linemen. So since the mean and the median are both larger for offensive linemen than defensive linemen, we're going to say that offensive linemen tend to be heavier.